So as you're going through the process of launching a startup, you're constantly trying to gain the ear of investors and convince them that your product is going to be a success. So you're going to hopefully start out with a great idea to begin with, right? And you're going to do some research, put together your business plan. You guys know all of this. Put together a patent if there's nothing infringing. And the step that a lot of people don't think about is that proof of concept and making sure you understand if your users need the product, if the technology can even be successful, can it work? And then also, are people willing to buy? So if you skip this step, you're going to have a much harder time gaining funding going into full product development. And when you get into full product development, there's a lot of costs there, as a lot of you know. So you're continuing to climb that mountain if you don't do proof of concept on something that is new, or even an iterative design that is going in a different direction and adding some new technology. So it's important to go into that space. Now, if you were able to prove that you're meeting your users' needs, does that necessarily mean that they're going to buy the product? No. No, it's important to understand the product cost early on. So back when you're even putting together that business plan, you should be estimating that cost, but you also need to get into some level of development quickly to understand what that cost can really be. So at Nectar, we have a product development methodology and process that we use for clients that come to us who already have their concept proven. So we go through these steps of discovery, so understanding what are the requirements, what are the risks, what is the business strategy of the product. And then we generate a lot of concepts and come down to one single concept that we're going to take into design for manufacturability. From there, we create what we call a pre-production prototype, so it's a pre-tooled prototype. And we can then test and refine that design. And then we go into verification and validation with tooled parts, manufacturing-ready parts. And then we sustain as well. When a client goes into full manufacturing, we continue and help them make sure the design is working and it's being produced well through the manufacturer. So this is great for when, again, a design is already proven, but when it's not, we really help clients understand how to quickly get answers and how to quickly prove their concept. So we take them through a fast feasibility cycle. And this can be done on a lot of different aspects of the product, which I'll give some examples of. So we quickly do discovery and concepting and even sometimes design of your product. And we do it only on the most critical factors. You don't want to be off designing the look and feel if you don't even know that the electronics are going to work, right? So this helps us explore key technical risks very quickly, increase confidence in your investors and yourself, hopefully, reduce the financial risk, and also manage costs. So making sure that you're putting the most dollars in the most critical aspects of your design before going forward. Now, some people look at this and say, no, I just want to go straight to product development. I want to go all the way through with everything all at once. I'm a risk taker. They think that it's going to cost more to do the feasibility steps and take more time. And honestly, I'd say it definitely shouldn't cost more. And the only way it's going to take more time is if you did have a proven product and you took the time to do this. So for example, think about if you're the owner of Fitbit and you want to add a feature to be able to project your results anywhere. So you can take your Fitbit and shoot your results out on a wall, anywhere you're at. And if you go into full product development on that right off the bat, you start designing, doing the industrial design, getting into mechanical engineering, doing all the user research up front, And in parallel, you're doing the electronics engineering to try to figure out what it's even going to take to add this feature. You could find out that you've wasted all your time on the industrial design and research and even engineering, mechanical engineering, just to find out that the electronics are going to be 5 inches wide by 2 inches wide in a T shape, and all the work that you did to create this beautiful design is not even going to fit, right? So in that case, you may have to redesign or reconsider that feature, and you've wasted time and money, right? So it is very beneficial to go through some quick iterations of feasibility. So here's an example of feasibility that we've been working on. It is an inventory management device. So it's a small device. It's about the size of a credit card and the depth of about 1/2 inch. And you can put these devices all over your supply cabinetry. And it simply has a take and return button. So you can walk up, anybody can walk up to an inventory bucket. Say you've got supplies like syringes. You can take 5 syringes, hit take 5 times, and then the system sends that number to the cloud software, and your inventory is updated. So this client came to us and they said, we really want to add some features. But they didn't know up front exactly what features the users were going to want. So we did some contextual research, as well as had a really fun facilitated workshop with the client. We got their cross-functional team together and our cross-functional team and brought together all the knowledge that we had of the different markets and the different users. And we identified what we wanted to add. And unfortunately, I can't tell you the exact features. In about a month or two, we'll be launching into manufacturing and commercialization, so we can talk then. But so we went through this step of understanding what the customers might need and want, and also what the client wanted. They were very excited about some of the features. And we weren't sure if we were going to be able to meet their cost target, because they already had an idea of what the price sensitivity was of these different users and customers. But they wanted the most features they could get out of this. And they also wanted to maintain that same credit card size and depth of 1/2 inch. And now that was a big challenge, because now we're adding features, we're adding electronics. And so our next iteration in feasibility was to find out, is that even possible? Can we achieve that same size by adding all these features? So we went through that iteration and found out that we could meet that size, but we didn't know if we could hit the cost target. So we went back in again, and as we were doing these different iterations, we were keeping cost in mind the whole time. We're always keeping cost in mind for our clients. But we did a final iteration to really focus in on cost and find out if we could meet their cost targets. And we ended up through a lot of searching for one of the technologies that we needed. We were able to hit their cost mark and go into full product development. So it was really beneficial to take these steps, because we did change course a little bit here and there as we went through these iterations. And if we had gone forward and made assumptions around what we could do and what we could achieve, we would have had to redo a lot of the work, especially the look and feel. So I'll just go through a couple of different ways that we can do advanced prototyping. Everybody's probably heard of 3D printing. That's the obvious one. But even in industrial engineering or industrial design, we use a lot of foam, right? You want to understand what is the form factor of the device and how does a user interact with it. So when you quickly mock something up in foam, it takes a couple minutes and a couple dollars, and you're already able to touch and feel what this device may be like. From a user interface standpoint, there's simple software packages where you can actually mock up an interface, hit buttons, and make them move to other screens without generating any code. From a mechanical engineering standpoint, we make a lot of breadboards. So this is a simple mechanism that's literally on a board. And we're able to test the mechanism, refine it, and make it work before we even put anything into CAD. And then from the electronics side, similar to the Somnology example, we can use a lot of different development kits. So Arduino boards and Raspberry Pis, like Francis had mentioned, among other things like the sensors having their own boards and libraries of data.